Hello, everyone.
Okay.
Welcome back to our YouTube channel, Becoming a ROS Developer. My name is Rodrigo, and today we have one of our students, Ali, who has completed one of our courses, ROS Basics, in 5 days. And at the end of this course, you're supposed to, in order to get a certificate, you can complete a project on a real robot. So we're going to be seeing what Ali did here. So hello, Ali, how are you?
Hi, thanks, Rodrigo. I'm well, and I did my project, as you said. Can I start my presentation?
Yes, go ahead. Whenever I see that you're already sharing your screen, so that's great.
Yeah.
You don't need to share it
Yes.
anymore. So please, yes, show us what you've
He-
done with your project.
Hello, everybody. I'm Ali Jafari. You can connect with me with LinkedIn, GitHub, Research, and YouTube. Uh, okay. Excuse me. Excuse me. Excuse me. In every live, we have something. Okay, I'm Ali Jafari, and can
Don't worry, I can see your screen. I can see your slides.
okay,
You're good.
okay, okay. Um, I'm Ali Jafari Fisharaki, and you can connect with me with these apps. Without any explanation, I can say I learned these materials in this course. I learned how is packages and what is node. And after that, I learned what are topics, what publisher, subscriber, and how object-oriented programming in Rust can I handle that. And after that, with the multi-threading executors and callback groups, that very useful for combination our services and topics together. And after that, I learned the service, server side, client side. How can I use custom message and custom services? And then I learned actions that are very useful in robotics and in ROS. And after that, with the debugging tools like RBS2, Doctor, Rust Doctor, and after everything that relates to that. And in the end, node composition is one of advanced topics which use just I think in C++ with the Rust too. Okay, when I started this course, it has some projects in actually besides materials that put on the course. I should do that to finish the courses. In each topics that you can see, we should go to the one project. You can see it here. That has some task for us to do it. It has some challenges for me because it has some differences, from course simulation to ROSGIC, because the LiDAR resolution and how the configuration, how the LiDAR assemble on the robot was different, and I should change my code to do that. Actually, I have some challenges with the simulation and something that connectivity with the internet, because that was one of the first one I used ROSGIC, and after that you should connect to the real robot, which was one of the amazing parts of these courses. And when you should book first the robot. Actually, in some days that I want to book, most of them was busy, and I hardly find one of them. And I had some challenges with right to the real too. And it was one of them that I don't know why, but again, it has some different resolution LiDAR and different setup configuration, because the head of the robot was different, and you should change all of them. And you had some challenges with that. When I connected to the real robot, I saw that it's one of the most challenges that you should set the rate of publishing and the rate very carefully, because if it is so high, is so high, you have some problem with the bandwidth with your network, and you have maybe some problem with that. And actually, because it was a remote and my internet, I know that it was on side of the remote, but I should change my little distances and little speeds to my robot work properly. Now I can show you how my robot works.
Awesome. Yeah, great introduction. So let's see what your project does. Yes. All right. So we see
First,
twisting.
find the nearest wall with the
Mm.
services. After that, it should start the wall following,
Yeah.
and it follows the wall in the corner, and in the it should turn, and it has some difficulties with these the value of the best value for changing the direction and how it should curve and make it move it circular,
All right.
because it determines the radius. I think it has some difficulties in the land in here, because every moment I see it's stuck there. Now it should stop because it passes one loop,
Mm-hmm.
and you can see here the action that it record odometry, because I changed the size of the window is small, but you can see
Yeah,
as
I can
a
see.
result it passes the odometry element, not odometry, the value that you wanted me to send it in the list. You can see I passed it as a result to and this is our feedback of the
Yeah, the
that
feedback of the action.
action series. Yeah, and it works very in a nice way. I have some challenges I mentioned before, and if you have any question, I can answer. I know a little. It was a little vague, and I couldn't explain it the whole process that I approached to this stage. But a little my plan changed because my video wasn't there, and I have some confusion in my mind. What
Oh,
should
do
I?
you have a
Yeah,
video that you wanted to show?
yeah, but can I stop the sharing to find that video and show you?
Sure, sure. Yeah.
Excuse me,
Yeah,
because I should find it in my the private file. Okay.
absolutely. Yes.
Can you see my screen now?
Well, I can see you, so no screen anymore. So you're safe to search.
Excuse me for that.
Don't worry.
Okay. Okay. Hmm. Videos like.
Any luck?
Yeah, a little time. I need a little time. Excuse me for that. No, maybe the time has passed, but if I can show you. Uh, Okay.
I guess it's been lost, huh? I'm just
Yeah.
wondering what's
Okay.
in the
Okay.
video.
Can you the question while I search it? Maybe I find it because you know.
What's in the video?
Okay, find it. I find it.
All
Thank you
right,
for the last
nice.
in the very last. Yeah. Do you hear it? Can you hear it or not? No, I don't
I
think.
cannot hear nor see your screen.
Okay, 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 okay. We can see my screen now.
Okay, yeah, now I see some files and oh, yes, and I can hear it.
I did this project mobile robot in our country for one of the prestigious campus. And after that, I did this multi-agent robotics in ROS. It was one of the great projects. It has a lot of challenges in localization and position estimation. This is a humanoid robot that worked on that. It's just one of copy robot to identify that. One of task planning robot, with a logo robot. One of my projects too. And I enjoyed the work for task planning. Thank you for your actually. And this is the uh, yeah, this is the simulation part. Uh,
I'm sorry, Ali, I can barely hear you over the music.
okay, can you hear me now?
It's the same. I can hear you, but
Yes, this is the robot that we had it in the actually in the course.
so you're applying the same program to that.
This the same program we had it this program, and I captured the video for my LinkedIn, but I didn't share it because the music was funny.
Nice, very nice. Thank you for showing us that, Ali.
Okay.
So let me ask you some questions, all right, about the project. Um, first of all, that's a really nice movement. So congratulations, really, really nice, really straightforward. My first question is, I don't see the list of odometry points as a result. Did you provide? Is there anywhere you're saving it? Can you show us where?
Yeah, actually, these are the list of the that you wanted me. They are not feedback. It's a result. You know, it's a feedback. No, and the result. Odon element 0, odon element 1, odon element 2, and I feedback that.
But I'm guessing. So the point of the action server of the odometry recorder was to record the current distance, the current points to which the I see the distance traveled. That's probably how you made it stop, correct?
Yeah, yeah, yeah.
So and then there was supposed to be a list of odometry points, so like the X and Y points that the Autumn server recorded. So I guess my question is, can we take a look at your action server code?
Yeah, yeah, why not? Okay. I think I had some misunderstand maybe. Think to. I should change my custom messages. Maybe. Okay. Maybe I don't pay attention more. Okay. Okay. Yeah, it's here.
Yes, this one. So what is this doing? I see you're doing current autumn. You're extracting the x and y positions in there, in your odometry callback. What is that for?
Actually, I did it for computing the distance.
Ah, I see. So you're actually extracting them, but then you're using it for the distance, and then that distance.
Yeah, because and I should do it in a different node because if I did it in this node, it has some problem with the because the rating and I use multi-threading and multi-thread executor to handle that. So I divide it
Yes.
in two parts.
Okay, so it's fine. I guess I just was wondering. You're obviously extracting the x and y to then get your distance traveled and then kill the node or kill the process or whatever once a certain distance is reached, or how do you determine that the lap has been completed?
Okay, I couldn't get what you mean.
How do you know? How do you know when the lap, when the loop, when the circle is completed?
Yeah, actually, I current odometry, I memorized that before the in this action server. I see in the action server. Yeah, yeah, it's the action server. Yeah, in the action server, I have a while loop, which first I get the start odom start
Uh huh.
position to minus that because maybe when you start it, it has some initial value. I see that, and after that, I said if it power the Euclidean distance is smaller than 30 centimeters, you stop. But you have a first and initial state in the same way. And when your robot starts, suddenly it stops. So you should have some distinctive condition to make it. You can distinguish between first start and the final. You know what I mean? Because when you start it, your
You're already
condition,
within that.
yeah, yeah, you are already in that, and so your condition is true, and it goes suddenly out of the loop. So I put the distance total distance greater than 2 meters, so it passes that, and
Uh huh.
on the one of the loop, and when it come back to the initial state, I break it. The
I see. I see. You kill it once you are. What distance is that? 2 meters.
2 meters,
So,
yeah.
but the loop is not 2 meters.
Yeah, yeah. The loop is, I think, it's 4 meters.
It's like 4 or 5. Yeah. So how did it know that it was supposed? Like, when does it break? That all right? I'm done. Is that line 113? Is that where it happens?
Yeah, yeah. It's freaks, and so it goes to the result of odom and succeed result. I pass
But
the result.
I guess my question is, wouldn't the node stop? Everything stop after 2 meters in this code.
After 2 meters.
So you have a flag in there. If the total distance is greater than 2, then you set your flag to true, and then you exit. Does that mean the robot stops?
Yeah, it freaks down the that, and I get the result. No, actually, get
But
the
it wasn't 2 meters. It was more than 2 meters.
yeah, I did it in the client node. You know, I said
No.
that. Yes, wait a minute. Following node. It's a client. What we call client node. I said when you get the result, uh, yeah, here. Your loop flag is true. Okay?
Yeah?
When you get the result and result received, I said that the loop flag is true, and so in the command publisher, I put the 0 to the linear x and angular z to stop the robot.
All right. I guess I'm still not clear on why it doesn't stop after 2 meters and why it stopped after four and something. Because
Yeah, because I have it. You know, the action result doesn't get after 2 meters because it doesn't go. You know,
uh-huh.
when your action finished, it gets the result to the client.
Yeah, yeah. How do you know when the result happens?
Yeah, from the client.
No, the server provides the result, not the client.
Yes, server provides, and how I can find out that there is a result. I put the condition on the client node, but the server can distinguish it with this loop, and when it goes to the go handle succeed, and
Okay.
you pass the result, and so the
Ah,
action server finish.
okay. Still not very clear on that, but all right. I understand your logic, but I just don't understand why there's a 2 in there. So I don't understand how it detects that it has traveled 4.5 meters and it has stopped. I still don't understand that.
You know, and what happened? What should happen to stop it? If I omit this line, it continues to the what happened? The robot suddenly stops because this wait a minute. Uh, Actually, I stopped it. Uh, Smaller than this.
Well, the robot would stop after that result you just showed me, and then the client would receive it and then send that 000 value.
You know, this is the final and start condition are the same, and I just put it this total distance that have different values total distance in the first start and the final one.
Okay.
Different. So I print it and it get the result.
All right. Okay. Great. And my other question was, what happens if you call the service to find the wall, but an obstacle is closer to it, to the robot?
It goes to the obstacle.
It will go to the obstacle. Okay, so you need to start it near the wall so it reaches the wall. Okay, great. And for the wall following node, I saw that the movement was very smooth. That was really nice. I wonder if you implemented some sort of PD control or if you just did an if and else.
Actually, I don't do the PD control. I just do the
Oh, if else. Oh, here they are.
yeah. You know, I first I want to do it by try and error, but I find that it's a very
Yeah, and it's not the point of the project.
I guess that from the kinematic of the robot. You know, when you have a linear velocity, example 1 meter, and you have an angular 1 radian per second, you have a 1 meter radius. if the controller of the robot works properly. It means the low-level controllers that I put I said that the robot goes 1 centimeter per second linear speed and it goes without any something. And I can guess it if I want to turn it under this diameter of radius, I should have this proper of the linear is to angular this. And this is the radius of the turning.
Okay.
Is that what I mean?
Yes. Yes. Great.
Cinematic thing.
Yes. And my last question, my last comment, I guess, is based on the challenges you mentioned that you faced, and that the differences between the simulation and the real robot. This is a suggestion sort of thing. So you said you ran into the challenges because it's different. So most of the times that's going to happen based on lidars, and simulations and everything. So you should code thinking on the length of the array. And let me tell you another thing about lidars. They usually attach them so it starts at the back. So the first value of the lidar array will be at the back of the robot. Most of the time. I don't think I've seen one that's different. And it goes counterclockwise, right? So it starts at the back and then it goes counterclockwise all the way around. Well, if it's 360, maybe it's not. But most of the time, the lidar that represents the front of the robot will be the length over 2. So a lot of the times, if you just consider that from the beginning, all the resolution differences and the resolution differences will be taken care of because you're thinking of the way it's built.
One thing, in the simulation, but the head of the robot is the 0 and 35.9. 359, yeah.
It is.
Yeah, but in the, as you said, in the robot, the head is 36 from 360 from the 720.
Okay, I'll review that because I'm pretty. I mean, unless I'm out of the loop somewhere, I think in the simulation it was higher resolution or lower. I can't remember, but both started at the back.
No, actually.
Oh, then I'll take a look at that because it shouldn't be. So it should be like the real robot.
Actually, even the counterclockwise and clockwise is different.
Oh no, that I can assure you. That is.
You can see it because I have I did this code with the real robot and the simulation at the same time with the ROS parameter. But I have some challenges in the simulation because when I run it, launch files, because the thread, it puts me out of that. Puts me out of the launch file. I don't know why. I tried a lot, but in the real robot it works. I don't know why in the launch file that I provided for the simulation I had this problem. But you wait a minute. You can see here. For the sake of find waffle. Excuse me.
Don't worry if you can't find it.
Okay.
Because we've run out of time.
Yeah, we can go, but you can see sign. I put it the sign and multiple with that.
Because it goes the other way around, huh? That's.
But this is the minus sign. You can see. You can see 3059, 359. I'm so bad in expressing numbers. What is and but in the you can see I use zero. And actually, I use sign because the singularity of the 0 and 30, 359. When I did this, I avoid of the 0 and 359 with the sign.
Okay,
Not
so I'll take.
controllers, but it's okay.
All right, okay, so I'll take a look at that because it shouldn't be. It should be the way. I mean, I built that simulation, and I, I
So sorry.
I did it pointing back and counterclockwise. I've never even seen that, but all right, that's fine. Good to know that you've considered these things. All right, so that's it from us, Ali. So thank you very much for presenting. Um, very, very nice presentation. And yeah, that's it. For everyone else that is watching, you can do the same thing that Ali has done here and complete your real robot project after you complete our courses. So that is it for us, guys, here at The Construct. We'll see you guys for the next presentation, and have a good day. Bye-bye.